Hi guys, welcome to Better Engineering Management Podcast. And today we have with us Mr. Mohit Shukla, who has been around in the industry for around 24 years, spanning from startups to multiple high growth MNCs like Infosys, SAP, and he has more than 24 years of experience where he has also created his own startups, multiple startups in fact. Mohit, please welcome to the show.
Thank you. Thanks for inviting me here.
Yeah, Mohit. Mohit, so how do you define what you do?
Well, my journey it started at a very young age. When I was about 11 years, I decided that I wanted to live in a boarding school. So I went there. And when I was in class 8th, I think 8th or 9th, something like that, that was the time when first time I got an introduction to what a computer is and I started using it. It was something new in our school and I was just amazed that, what this thing can do. So in during that period I started learning a language called QBasic. So that was the first language that I learned. It's called basic, stood for something like beginners all purpose symbolic instruction code. It was given by Microsoft and it used to run on MS-DOS operating systems. Then after class 10th, when we were in class 11th and 12th, we had to choose the subjects because in my school, you could either take biology or you could have taken maths. Sorry, either you could have taken biology or the alternative was computer science. Physics, chemistry, maths was common for everyone. So I had already learned one language. I was fascinated by what computers could do, and I chose to take computer science as my subject. There in 11th and 12th, during those days, we used to learn a language called Pascal. I don't know if anybody uses this
I
language.
have heard about it, yes. Haven't done anything on it, but yes, we have.
So
Yes,
that
it was
was
one of the languages taught. Yeah.
my second language that I learned. And I was pretty, during the school days, I was learning at a slow speed. And then, as luck would have it, I was expelled from my school in class 12th. And during the time when I was expelled and I was at home, not in the boarding school, that is when I really learned Pascal properly. And I felt I was
Okay.
really good at it.
Okay.
Anyways, I completed my class 12th and then come to engineering. During the engineering, as part of our subjects, as part of our curriculum, I learned C, I learned C++, and then there used to be old languages called COBOL and Fortran, which I learned. So by
Okay.
the time I was here, there were six languages that I already knew. Then during the final year of my college, I was working on a project on my own. I had some idea of making a text to speech engine. It's very common these days, but those days it was not
Right. You,
common, and I started making that. That was like a fun project I was doing, but it was really coming out well. But to do that, I had to learn a language, another two languages called Visual Basic and Visual C. Again, these were Microsoft languages. So, yeah, so by the time I graduated, I already know around eight languages.
wow.
And I loved it. I mean, I think
Okay.
somehow coding came very naturally to me. I loved it. I'm an introvert by nature, and I think people who want to sit alone and do things, and you do thing, you program something, and you get an output, it is so satisfying. So yeah, so I learned all this. Then my first job was in Bangalore. It was a US based startup.
Okay.
There I learned newer languages. So what used to happen was every time I would move to a new company or a new project, for maybe it was some sort of a coincidence that it was always a new language that I had to learn. So here in this company, I was working there for about an year from 2001 to 2002. I learned PL SQL. So PL SQL is a language which works with SQL databases, Oracle databases. I think it is, if I'm not wrong, PL SQL is by Oracle. So I learned PL SQL as a language, and I learned a lot about Oracle databases, Oracle Forms, and Oracle reports. So Oracle Forms are a front-end builder tool. I don't know if it is
Mm-hmm.
or not. Those days it was very popular. Oracle Reports was a data visualization tool. So learned that. Then my second job was with Infosys. There I learned a language called ProC. ProC was a variant of C which was specially, I think, developed for dealing with databases. So I learned ProC, I learned Unix shell scripting, and there then I learned Java. So, and then I joined SAP. Once again, SAP uses its own language called ABAP, Advanced Business Application Programming. So I learned ABAP. So by the time all this happened, and then after that, I started my own startup where little bit I learned, little bit, not too much. This was really, really, really little bit. I learned about Python, about JavaScript, HTML, CSS. So you see, over a period of time, something by somewhat by chance and somewhat by interest, I know now 16 languages.
It's
I'm not
really amazing.
proficient in all of them. In some, I'm less proficient, but in some, I used to be really, really strong. And that's how my career went on. I kept learning new languages, kept learning new technologies. Overall, my experience is split between large multinational corporations like SAP and Infosys and a very dynamic world of startups, both as a founder of a startup and as a collaborator in a couple of other startups. By collaborator, I mean, more like an employee or at a junior level, at a senior level. My core expertise lies in handling teams in application software development, right? Guiding rails to teams in form of processes, tools, techniques, etc. My interests also go beyond technology. I'm a very avid reader. I read a lot about various subjects like history, economics, finance, strategy, entrepreneurship, emerging technologies. Recently, I've been very fascinated by neuroscience.
Okay.
So I read a lot.
Excellent.
I'm an active, yeah, I'm a very active stock market investor, driven by my goal of financial independence, retire early. So, anyways, retirement has still not happened, but financially independent.
Right.
Fun. It's
Understood.
it's really fun to be financially independent when you are no longer dependent upon your monthly salary. It's
You
very
can do whatever you want after that, at
You can
least.
do whatever you want. I can come here talk to you
Sure. So, Mohit, you have more than 2 decades of experience, right? A very rich experience where you have worked with largest companies as well as startups.
as well as startups. And
Okay,
and
correct.
one more thing. I missed one thing, very
Sure.
important. So now these days, there's a new passion. I am writing my first book. It's called The Textbook of
Okay.
Happiness.
Okay. We
So I
surely discuss
started
that
the
also.
journey of writing a book. I have two wonderful sons, aged 12 and 8. 12 and 8. That's me.
Thanks for the introduction. So, Mohit, what I was asking is, can you share a real world challenge which you have encountered where the engineering team has faced some situations or some challenges and they had to evolve really quick and address that challenge?
So lot of situations where engineering teams face challenge, they have to rapidly evolve. Especially it happens in startups where things change very, very fast. In my own startup, which I ran for about 6 to 7 years, we were
Mhm.
developing CRM, a customer relationship management application, and what we thought is that we'll bring CRM onto a mobile app for small businesses in India. So we started building it. The product, in my opinion, was very good in terms of quality, in terms of the ease of use, etc. We used to get a lot of good feedback from the people who used to use it. But maybe because our focus was more towards engineering, what happened was that we were not able to gain a lot of revenue out of that product. And then when I would go and try to sell this product to many of my potential customers, what they would want is they would say, okay, mobile phone CRM is good enough, but what we really want is if you can build us a website where all the CRM functionalities are built in. So at a very rapid pace, the moment I realized that, market needs something else compared to what I'm building, I had to realign my entire team, and then we built our web application builder platform. And that actually started getting, the business started growing very fast. And that did well. So, such kind of pivots are often needed. You have to listen to what market is saying and quickly adapt to it. And it is one thing as a founder adapting to a new idea, but aligning your entire team sometimes take time. Luckily, I had a good team, very quickly aligned to it. So, yeah, this happens. Some of the experiences I learned from this change is that scaling engineering is not just about writing code. It's about being very flexible. Your teams have to be flexible, your product has to be flexible, many things
Hmm.
have to be automated, and the quality has
Okay.
to be good. This flexibility has to be baked in early into your product management, product decisions, architectural decisions. If you don't have a very flexible architecture, it is difficult to be quick to respond to what market needs. So early technical debt in startups becomes a bottleneck for growth very, very fast.
Okay. Okay. Okay.
Those kind of problems happen.
Hmm.
Change has to be embraced. With technology is changing so fast and business needs change so fast, as we go to market, we learn new things, so we need to be
Right.
ready to embrace change. We need to invest in learning at a
Right.
personal level. And when we are running a team, running a company, we have to invest in continuously upskilling our teams. Those kind of things help.
Sure. Okay. So my next question is like your experience in SAP, and you have also worked with various AI-driven products, right? So how did that shape your perspective on modern software engineering?
So fundamentally, my view is shaped from 2 points. One, working in large companies like SAP. Secondly, working in small companies. My earlier startups, my own startup and the earlier startup where I worked, those were pre-AI kind of days. Now in last 2 3 years, AI has gained a lot more traction than what it
Right.
used to be. Organizations, and especially large established product companies, they engineer for stability and scale. So I used to work with SAP. It's a German company, and I think Germans as a culture are very, very quality conscious. They are very accuracy conscious.
Okay.
And I used to work there on core banking, ERP products. If you have to sell your product to a bank, or if your product has to be, if your ERP has to be used by very large multinationals like Walmart, like Nestle, etc., it has to be extremely stable.
Quality has to be high.
Quality has to be very high. It has to be very stable. You can't have problems and bugs reported by customers very frequently. So that is a very top priority for those kind of large product companies. I learned my lesson to never compromise on quality on each step of engineering. Quality cannot be an afterthought. It has to be taken care at each step of engineering. Rigorous processes have to be there, backward compatibilities have to be there, etc., etc. So all this taught me the importance of very robust architecture, modularity, well-defined processes, something that fast-moving startups, they often overlook. In startups, the world is very different. I co-founded EQ Tribe and later worked at two other startups, and one startup I worked in early in my career. The mindset is completely opposite. Their speed is prioritized over perfection, and which is right, which is for an early stage startup, it's a good thing. You have to be very, very fast to quickly build your MVP, take it to the market, get the market feedback, and then continuously evolve your product. So it is very important. Here in startups, engineering need to be lightweight, fast, and constantly evolving. Unlike in a place
Right.
like SAP or a Microsoft or in any large company where long planning cycles are there, you will plan for a release which is going to happen after 6 months, after 8 months, etc. In startups, you are shipping new features every few days, every few weeks. You're not thinking in terms of month. You have to think in terms of days and weeks. You have to experiment very rapidly, pivot based on real time feedback. Working in these kind of environments, it taught me the importance of balancing agility with scalability. So how do you quickly build without accumulating a lot of technical
That
debt?
and okay.
All this shaped my perspective. Modern engineering needs a hybrid mindset. It cannot be totally a startup like mindset. It cannot be totally a large company like mindset. Because if you completely go with what people call a startup like mindset, in few years, what happens is you have a product which is of poor quality. Sometimes it
Mm.
fails, then customers are unhappy. If you are completely on that other side of the spectrum where everything is following long planning cycles, then you can't be agile. So you have to mix these two things. So it's no longer about just building the software. It's about building systems that learn and adapt and improve over time. Systems need to improve over time. Role of engineers, it's heavily changing. It's not about coding anymore. A lot of coding is done by AI these days. Engineers have to do problem solving across the business, and they have to do a lot of automation.
A
So
lot of collaboration has to happen across the
a lot
teams,
of
and
collaboration.
overall product will come out of that.
Right, a lot of collaboration has to happen. They have to think beyond
Right.
their traditional software development. They have
Right.
to focus on scalability, focus on, being very data driven. Decisions have to be
Okay.
taken on a data driven. And in last 2 3 years, things are changing very, very rapidly. Now you have to, I think, like 8 9 years back, the buzzword used to be that you have to be mobile first. Your architecture has to think mobile first. When you are thinking of even before that, people started saying, when I started my career, the typical way of designing a system is you would start with designing your databases.
Right.
Then you will think of rest of the backend, and finally you will think of putting a UI over your backend system. Then the buzzword became that it has to be a UI first kind of an approach. You first build your UI
Right.
and then think of backend. Then
Right.
8, 9 years back, it became mobile first. You have to start thinking how will it work on a mobile environment,
Mobile
on
app.
a tablet, on a
Correct.
phone. Now, I think now the change we are going to see, and we are to some extent we are already seeing, but existing companies are a little slow to adapt. The change that we are going to see is in next 5 years, 10 years, everything has to be AI first. You have to start thinking AI first. How artificial intelligence will be used to make your system, autonomous. How do you use AI to make your system autonomous? It can have real world impact. Every application will have to have their own AI strategy, and you are already seeing that happening. You see already on Google Drive, on Gmail, you have AI on Microsoft Excel sheets. You have AI. I
Right.
see already on very popular tools like Jira, like Confluence, like
Mm-hmm.
Studio Code. All tools are now, you
Using
know,
AI at some level. Right.
not some level. They are actually embedding it at
Correct.
right on your face. You just can't escape it.
Yeah.
But
Even we had some experience with tools like Code Whisperer, which you can directly integrate it in your IDE, and it will start suggesting code based on your existing code repo, and can kind of also it can totally align itself with the code quality that you are already using, the coding structures, the kind of things you are using. So you are right. I mean, it is totally changing the way you write code.
hmm, hmm. But Pradeep, what will now happen is I think see what it was around November 2022, if I'm not wrong, when ChatGPT was
Made the buzz,
suddenly
correct?
mass available to all of us, right? Somewhere around the end of 2022. Now, what's going on since then is after ChatGPT and AI became a common language, everybody started to know what it is. Even the people from not from AI background, even those who are not from technical background, everybody started to see the power of AI. So last 3, 4 years, the trend that we are seeing is that first there are few companies that own your artificial intelligence technology, whether it is Microsoft or GPT. GPT is Microsoft only. Whether it's your Microsoft, GPT, maybe Google, Facebook. Some companies own these large models running on very, very powerful infrastructure. Rest of them are consumers, right? And what people started to do was that there were already existing products like Excel sheet and Google sheet and Google Doc. They're existing. It is existing from last 25 years or so.
Yes.
It is existing from at least 10, 15 years. All
Hmm.
these tools, whether you are using Jira, Confluence, whatever, or Visual Studio Code, anything, tools were already existing and people started to plug in AI into that. We have seen this wave happening already. We are
Right.
seeing it all over.
Right.
Every tool is trying to plug in AI over their existing system. Like you go to any diagramming tool, whether it is Miro, whether it is Lucid Chart, etc. You go to any diagramming tool, they are adding AI extensions to it. But I think this is something that people who were not prepared, and because now AI has come, they are suddenly somehow trying to plug it in. The real wave is, which is now going to start, and especially with all this deep seek and all, which is bringing the cost of AI down. The real wave will be when the newer products will be made with AI first approach. Current use of AI is not AI first approach, right? Here you are integrating AI on the existing tools.
Existing system, correct. You're right.
This will, I think, slowly it will shift towards AI first
AI
approach.
first.
That's
Okay.
that's that's the shift I think which we'll see in next 5 years or 10 years. And it has begun little bit in tiny bits and pieces, but this will speed up.
Okay. So can you tell me more? But when you say AI first, you mean the products will be made thinking, taking the advantage of all the AI related technologies first, and it's not like something is already made and we are just embedding AI into that. That's what you're trying to say, right?
Yes, something which
Okay.
is already there, embedding AI is not an AI first. That's an you are extending your product. You are plugging in AI
Right.
into it.
That's more like a plugin. Correct.
What I'm saying is new use cases will start arriving very
Hmm.
soon in front of us. Like for example, in 20, 30, 25 years back, there were many use cases which did not exist altogether.
Okay.
Nobody thought 30 years back, most of the people were not thinking that, all our shopping will happen online. So
Okay.
new
That's
use
true.
cases emerged because a technology came. And a
Correct.
business like Amazon or Flipkart was a online first approach. They started online, right? And then they built rest of their infrastructure.
Right.
Similarly, now we'll see new use cases coming up, which will be AI. They'll start with that.
Sure. Uh, True. I agree. I think that's going to happen very soon, and we are going to see a lot of products which will be built with AI first mindset.
Hmm.
Uh, so Mohit, you have led engineering teams across multiple domains, right? Like logistics and e-commerce and banking and even medical and imaging, right? So if you have to kind of mentor your younger self today, right? What kind of leadership mistakes you will warn yourself against?
If I have to mentor my own younger self, wow,
Correct.
very nice question. So I've made my fair shares of mistakes as a leader,
Okay.
as an entrepreneur. I've made a lot of mistakes, but each one has shaped how I approach engineering and leadership today. All my
Mhm.
mistakes, in a certain way, I would say for myself, and maybe it is true for everyone, we all are products of our mistakes, right? We learn from our mistakes.
Yes,
And
completely agree.
that shapes the way we think. And I've made a lot of
Correct.
mistakes. I tried to do a lot of things, and in those, I made my own mistakes, and I had gone through my own learning curve. So, if I were mentoring my own younger self, now maybe there are a few, let's say, three critical lessons I would emphasize. One is clarity is everything. Set a single, unshakable vision. Second is power of saying no. And third is technical debt is a silent killer. Let me elaborate on each one of them. First one. So, first is clarity is everything. Set a single, unshakable vision. So, as a leader, your team needs absolutely clarity on what you are working towards. You know, I have seen situations where while the founder or the top management of the company is very, very clear what they're trying to do, but somehow the teams are not so much aligned with that vision. They don't even understand. So think clarity like a single one-liner mission statement, something that is so simple that everyone from an intern all the way to the CEO, everyone understands it instantly. Whether, like, for example, there are, it could be like sending humans to Mars. Everyone can
Correct.
understand. Or let's say building AI powered digital pathologist. Everyone can
Mhm.
understand. The goal should be
Great.
obvious and unambiguous. Without clarity, teams waste time and building great solutions. They just waste time building great solutions for wrong problems. They don't
Teams
have,
will be confused and they don't know, they are not aligned with the vision of the company, the higher vision, and they kind of get confused amongst themselves. Like they may,
yes.
smaller visions they may start having rather than getting aligned with the final vision of the company.
Yes. Sometimes I have seen in my past experience, sometimes I have seen that forget employees, sometimes even the founder is not very clear about the vision. Their own
Okay.
vision keeps changing. So they build one product, and in between somebody tells them to become a marketplace, and then they try to
Hmm.
become a marketplace and things like that. So
Correct.
clarity is everything. One single unshakable vision. Next is for an entrepreneur or for anybody, power of saying no. So, one of the hardest lessons I learned, especially as a founder, is that leaders must say no more than they say yes, not just to customers, even for themselves. You see, Pradeep, new ideas they come up every day. If you are a creative person, every day you will think of a new idea. As engineers, product leaders, we get very excited about new possibilities, new ideas. I'm trying to sleep, and maybe in the night I'm thinking something. Suddenly, I get a new idea. I get up in the morning, I get a new idea. A lot of ideas come sitting in the loo. So
Correct. Can't deny that.
we have a lot of new ideas, but there is a harsh reality. Harsh reality is if your team, let's say, just for the sake of example, let's say your team needs 100 days to execute an idea, but you are generating a new idea every single day. You will drown yourself in unfinished projects or unfinished features or poor quality products and features. So you need to have the confidence of saying no to 99 of your ideas so that everybody can focus on that one single idea that moves the needle the most. So power of saying no is very, very important. And the third point that I mentioned was that technical debt is a silent killer.
I think that we have also experienced couple of times in our, and I think in every company where I have went, this is one thing that I have also dealt with, and kind of it has made our life very difficult because a lot of resources go in. Please carry on. Mohit.
No, you're right. You're absolutely right. A lot of resources go in, and this one is for, especially for engineers. Don't ignore technical debt. You cannot save it. You cannot escape from technical debt. It's easy to think that I'll fix this bug later. Right now, let me ship this new feature. That
Mm.
later never ever comes.
That's correct.
Over time, bugs accumulate,
Mm.
workarounds pile up, and before you know, you are spending more time fixing problems than innovating. So
Yeah.
I have seen places where entire engineering team 90% of their time, 95% of their time, it is going in either solving the bugs that are found by their own testing teams or solving the problems that are reported by customers. So
Right.
they are just solving those problems, and then the customers are also unhappy and the tech debt is just piling up, and worse, those little bugs. What are those little bugs? Every bug, it's a symptom of a deeper architectural flaw. So I think people should think like building a skyscraper. It's like building a skyscraper on a weak foundation. No matter how slick
Mm.
it looks, it will eventually collapse, under
Right.
its own weight. The best teams fix issues at the root, not just surface. So every time a problem is reported, we have to always keep enhancing our architecture, the design, not just put a band-aid and solve it. So these three things, people have to
Careful about.
startups, maybe also larger organizations, but more so for startups, they have to take care of, be crystal clear on your mission, say no to distractions. There will be a lot of distractions, very exciting distractions, say no to them. Fix
Hmm.
problems early, don't let them snowball. Those are the three things I will say every budding entrepreneur should learn.
Mohit, you also mentioned that you have been writing these days, right?
Hmm.
So, what inspired you to start writing? I mean, in spite of having such a busy career, right, in software engineering, what inspired you to write and what are you writing these days? Please let us know.
Yeah, I'm just loving. So, this thought of writing used to come to my mind on and off, but I never really started with this. And I always told myself I'm too busy with the work and my office, my job, my setting up my own company, starting my company, running my company, closing my company, whatever I'm doing. So I
Hmm.
always, would say that, "Arey, right now I'm too busy. Maybe I'll write later." The truth is, writing isn't something writing isn't something you find time for. It is something you have to make time for. So I have started to believe that writing is one of the best ways to reflect, share your insights, connect with people on a deeper level. And as I write more and more, and for my book that I am writing, this book is called The Textbook of Happiness. The more I write, the more I introspect. It's not just I am able to connect with others, maybe somewhere I am able to connect with myself. What inspired me to start writing? So for years I've worked with in very high pressure environments, leading teams at large and small companies. My own
Right.
startup, it was again a very high pressure environment. You are always stressed. So along the way I've seen how stress, burnout, and constant pursuit of success and money affects people, including myself. Okay, including myself. This, we somehow learn from our childhood that we measure people in terms of how much money they have. In either, we often don't know how much money exactly they have, but we measure people in terms of how big their house is, which car they are driving, how many cars they have, what kind of clothes they are wearing, how expensive, what are their expensive destinations where they are going for vacations, etc. etc. It's all about money. So we measure others, and more than others, ourselves, from the parameter of money. Now, constant pursuit of success and money, as I said, it creates a lot of stress and burnout. Personally, it impacted me, my family, my children, my friendship. They were impacted by this pursuit of success. You might not like me using harsh words, but I think our society is headed for a mental health pandemic.
Okay.
Recently, there was this young girl from Kerala. We all heard this news. She was working in a large multinational accounting firm. I don't want to name the firm, who committed suicide. You would have heard this news.
Right. Sure.
It was just a few months back. And
Hmm.
there are so many more such cases which don't even get media attention.
They don't
So,
get surfaced.
sorry,
They don't surface on the media, but they are happening.
yeah, they don't surface. In this case, because it happened in a large city, and that too because the company which she was working in, it's a very well-known multinational firm. Because large names were associated with it, it got a lot of attention. But Look, while young folks are driven to suicides. Some of our top industry leaders are talking about 90 hours of work a week, 7 days working a week. What is this going on, man? What is this? Like, can't we just see that how this is related? What is this going on? So, despite
Bound to
achieving
affect the mental health. Correct. You're right.
all this is impacting our mental health. That's why I'm saying it's a pandemic. It is going to be of the scale of a pandemic. Now, despite achieving so many milestones, I often found myself wondering that does success automatically lead to happiness? And when I say success, as our society mostly, when we talk of success, in some or the other way, we are talking of money that is earned, right? We are
Correct.
not talking
Correct.
of success in terms of how good I am making an art. My art is also, I will be considered a successful artist only if it commercially sells.
I think if
So
how healthy you are mentally, if that becomes the criteria of success, then things will be completely different.
yes, yes. So when I was these thoughts were always in my mind, and this curiosity, it led me down the path of exploring happiness as a subject, not as an emotion, but as a
Okay.
skill that can be learned, practiced, mastered. And I started reading, researching, reflecting on what truly makes people fulfilled, what gives that feeling of fulfillment, both in personal as well as professional lives.
Capacity. Okay.
So then I started writing this book. It's called The Textbook of Happiness. It's not a self-help book. I don't want to write a self-help book. It is not about abstract theories or fleeting motivational quotes. What I'm writing in this textbook of happiness is it's practical, actionable insights on what you can do to make yourself happy. And the book explores the science of happiness, from the point of view of psychology, neuroscience, philosophy, that tell us about lasting happiness. It explores topics like how societal and family expectations drive us into a rat race, which results into unhappiness. Like somebody dying, somebody committing a suicide because being overworked in office. Why would that happen? Because first of all, that somebody thinks that I need to somehow keep working for 90 hours a day so that I can get some material success. On the other hand, the bosses of that place might also be a product of some sort of a rat race. They themselves think that unless they are working day 24 by 7, and they make entire team work 24 by 7. So where
They
is
are under the same pressure and they are applying the same pressure
they
on
apply this.
downwards also.
Where is this all coming from? It is coming from expectations that our society and our family puts onto us. And third topic I'm dealing with in this book is everyday practices for a joyful life, for a happier life. Simple, effective habits that anyone can implement to be a more balanced, joyful, and to have a more balanced, joyful, and meaningful life. Why is this writing matters to me? As much as I love technology and AI and engineering, no amount of innovation matters if the society isn't happy. We chase productivity, success, efficiency. But what if happiness itself is the ultimate life feature we should be optimizing?
Hmm.
So I think writing this book is a kind of a journey of self-discovery. I hope others find clarity, purpose, and true commitment in their lives by some of the things that I'm trying to write here. At the end of the day, happiness isn't a feeling, it's a skill. And it's a simple skill. Everyone can learn. All of us can learn. Nobody teaches us. You go to school, you go to college, you are taught physics, chemistry, maths, biology, but nobody is teaching happiness.
That's true.
Right? And that's why
Right.
I titled this book as a textbook.
Really looking forward to that book, Mohit. I mean, the description which you gave, right, it has really kind of excited us all.
Yeah, I'm enjoying as well. I'm enjoying the journey.
Sure. Looking forward to that book actually. So, Mohit, coming back to our topic, you know, you've also seen a lot of traditional software engineering practices, models, right? And a lot of the way current software engineering models work, right? What do you think has changed and what still needs to evolve?
So the traditional engineering models, especially the software
Hmm.
engineering models, they
Hmm.
are built account predictability, stability, and long-term and long development cycles. Okay.
Okay.
Any
Okay.
large MNC, you see, companies which are making systems for hospitals, for banking, they are making ERPs, financial markets, etc. All this needs very predictable and stable technology. So during this process, that traditionally the way industry evolved, the way business software evolved, the entire focus was on very rigid process so that lesser and lesser problem happen, waterfall development, and minimizing risk at all costs. So, but modern product engineering, which we have now started to see in many of the modern startups, this is all about speed. It is about adaptability. It is about continuous delivery. Why speed? Because your business requirements are changing very fast. Every new customer you take your product to, if it's a new product, every new customer comes up with their own nuanced expectations, and then you have to quickly do for them. So on one hand, customer expectations are changing very fast, market expectations are changing very fast. On the other hand, technology is evolving very, very fast. Just 5, 10 years back, because the common people were not talking about AI, about computer vision, about robotics, about self-driven cars. Now, today, somebody asked that, okay, if a car can be self-driven, why can't your system be self-driven? Things are moving very, very fast. And so we have moved from very long release cycles to weekly or even daily deployments, from monolithic architectures to microservices, fixed hardware-based systems to cloud-native AI-powered platform. Things are changing and changing very fast. What has changed? So from project-based approach, we have moved more and more towards a product-led thinking. You know, what does it mean? Earlier, engineering teams worked on large predefined projects with very rigid requirements. Now, teams operate with a product mindset, continuously iterating based on user feedback. Olden days, initial half of my career, when people used to work in waterfall model, from there we have evolved to agile and DevOps driven development. Instead of long planning cycles, software is built very incrementally, shipped very faster on a weekly basis, a fortnightly basis. We are shipping new features to the market. And then, of course, AI and automation are becoming the essential part. So, what still needs to evolve? All this is changing. What needs to evolve? Two, three things need to evolve in terms of the way teams work. AI native development has to be. I spoke about it a little back also. AI native development has to be started. We have integrated AI into products, but engineering processes themselves haven't fully adapted for. So AI should be very actively used in code reviews, testing, deployment pipelines. Some engineers have started to use in their coding work, but there are many others who are not doing it. In some cases, some developers say that I don't want to use AI for coding because maybe that will hamper my learning. I've heard this answer
Right.
from someone.
Right.
So in some cases, company leadership itself. See, what happens in many companies, leadership is of old school of thought. So they are finding it very difficult to take a leap towards AI tools, and all these AI tools are expensive, right? Because why are they expensive? Because they are claiming. I'm using the word claiming only because of DeepSeek's intervention. They are saying that they have to run on extremely costly hardware. So they are expensive.
Right.
Leadership often, they are still old school of thought. So they are finding it difficult to adapt. It's there. Technology is there. People are not adapting enough. Then another thing that needs to evolve is ethical and responsible engineering. As AI takes over decision making, we need stronger frameworks for transparency, fairness, and accountability. Companies have a fear, and legitimate fear, that what if my IP goes into a third party model, and then this model is able to give answers to others which is based on my intellectual property. So far this fear was not there. If your intellectual
Right.
property is in your documents are on your servers, even if they are on cloud, you knew that it is in your control. But if your intellectual property is part of a publicly used model, AI model, then it is. So maybe we need to rethink the way we deal with intellectual property itself. Can it really have, can we really safeguard it? Or maybe the idea of safeguarding intellectual property to the way it is done today, maybe that needs to change. I don't know. And then beyond just shipping features, the next evolution of engineering is about building fast. Is not just about building faster, but building better. We need to have focus on sustainability, security, long-term maintainability. Security is going to be very, very important with AI. So yeah, in short, engineering is shifting from writing code to building intelligent and evolving system. It's a very exciting transition. It's going to be amazing, Pradeep. Next 10 years, we are going to see so much of change around us. It will be really amazing. I think the world of 2035 will be unrecognizable. If somebody sleeps today and wakes up in 2035, he won't be able to. This earlier, this cycle used to happen for 50, 100 years. If somebody would have slept at the end of at the end of World War 1945, somebody sleeps and wakes up in 2000, the world will be
Mm.
very, very different. So
Right.
what used to happen, the amount of change that would happen in 50, 100 years, we'll see it in 10 years. reviewing them and making correction because AI also hallucinates. So these days, I'm able to get a lot of help from, for example, tools like Confluence AI, Jira AI, ChatGPT. I'm using it so much, What used to take me earlier, to a document that I would take, many days to write. Now I'm able to finish it in a few hours, maybe within one day, what would have otherwise taken me a week. And also the quality of this documentation, the structure, the grammar, language, everything is good. Then, so that is about the documentation part. Then the next is, uh, I was seeing just a couple of days back, Pradeep, I noticed that now in Jira, if you define, let's say, your epic nicely and add a few stories, it gives you an option saying that do you want to add more stories? And what it does is I think it reads all the other content that is already there on Jira and on Confluence, or I don't know what it reads. It actually suggests you that what all user stories you are missing. It's amazing.
That's very interesting.
It's very interesting. So an activity like writing requirements clearly is
Hmm.
helped very heavily now by Jira. It's interesting, it's super fast, and I noticed that what it suggested me, it's like I was working on a project and it suggested me some 7 or 8 new stories. Two of them, maybe three of them were really crap. They were useless for my use case, but remaining were very, very relevant. And it helped me. It saved my time. And it's not only saved my time, it helped me think about those stories early on rather than, do. So that is about these activities, about writing
Hmm.
architectural things or writing the product, doing the product definition, user stories, etc.
Hmm.
Then code
Okay.
generation and review, AI-powered tools like GitHub Copilot, ChatGPT. Now they are assisting developers by generating a lot of boilerplate code, suggesting improvements, even detecting vulnerabilities. You are writing code and it is telling you where the vulnerabilities is. Earlier, we used to do this using static code check tools, right?
Static code checkers, correct.
But anything that happens later, if you are able to do it earlier, it's always beneficial. A lot of CI/CDs and testing is now getting AI is helping us in automate that. So regression cycles will reduce as we integrate AI more with our testing. I'm already able to write test cases using AI. So if I have a lot of product information and architectural information in my Confluence is able to generate test cases for me. Pretty powerful. Debugging, people are using it, root cause analysis it is helping in if there's a problem. So a lot of things, yeah. So it is key takeaway is that AI is making SDLC faster, smarter, more data driven, shifting the role of engineers from manual coding to high level problem solving. Coding is becoming easier, but people have to focus more towards high level problem solving, optimizing what
So
is generated.
all this leads to the very important question, Mohit.
Huh.
Will AI replace software engineers or will it augment their capabilities?
It won't replace. I don't think so. A lot of people think that it will be replaced, and yes, of late there are news that many large companies have been firing, laying off, etc., etc. That could be different reasons, but I think in long run, maybe in short term, people will think that it will replace. It won't
Hmm.
replace software engineers. What it will do is it will redefine their roles. It will redefine their roles. And let me give you another example. Let's say many of us would have tried, you might have tried, if you ask GPT some health related question, it is giving you pretty good answers, right? A few days back, I went for my annual health checkup and I got all these, reports which were in PDF formats. All my blood test reports, stool test report, this report, that report, CG, some X-rays, etc., etc. So what I did was I took all these reports, they were PDFs, and I uploaded it to ChatGPT. And I simply said that based on these reports, if you are a general practitioner, what will be the suggestions you give? And it gave me a list of suggestions. I was just trying to play around. So it
Okay.
gave me a list of suggestions that this is you are bad on this parameter, and
Okay.
you have to
Okay.
do this, you have to do this. Some simple, easy to understand English text it gave me. To cross check this, I have a very close friend who is a very accomplished surgeon. So I gave my reports to him and I said, hey, you know what? This is the answer GPT has given me. What do you think about it? He was amazed. He said, yeah, this is very, very accurate. He said, Mohit, I would have said these things to you myself. What you are
Wow.
getting from GPT. Now, what is going on here? What a doctor would have done, a tool is doing. And the doctor is confirming that yes, the answer is pretty good. Does it means we don't need doctors anymore? No, absolutely no. Look at it like this. In a country like India, or maybe it is true globally as well. In a country like India, we have a certain proportion of doctors versus population, right? Proportion is today not enough to provide a good health care to our entire citizenry. Not everybody
Right.
is able to get good health care, right?
Sure.
Because we say that our doctor to population ratio is not good. Now, if a lot of doctor capacity is augmented by AI, what will happen? Maybe the same set of doctors will be able to cater to larger population in a better way. So it's not that we won't need doctors. We'll need them. But they will be able to serve. If one doctor in one day, if he was able to on an average help, let us say 10 patients, maybe with this power he can help 20 patients. And because the supply is so, sorry, the demand is so high, it is not fulfilled anyways. It's not that doctors won't be needed, just that they'll be able to provide better health care to more people. That's it. Same happens to
Whenever it's a missed opportunity which can be plugged in by AI, right?
absolutely,
Helping professional
absolutely.
skill. Okay.
Absolutely, absolutely. Same will happen now. Same thing will happen with engineers. It's not that software engineers will be replaced by AI. What will happen is AI, see, what will happen is same software engineers will be able to now produce more software and better quality of software, maybe faster software, maybe many new use cases, which we are not doing today because of our limitations in both capacity as well as technology. Uh, so AI still lacks human creativity, problem solving, some level of creativity. Yes, I understand it generates pictures and videos, but certain level of human creativity is still done by humans. And I problem solving also. Yes, many kind of problems are solved, but when it comes to more complex problem solving, I think we still see humans being getting involved. And strategic decision making is also something, even if AI can do, people will want to remain in control. So those things are not going to go anywhere. And software engineering is not just coding. It involves writing architecture, it involves thinking system design, it involves stakeholder management, a lot of ethical considerations. AI can generate code, but it still needs human validation. It still needs
Also, there has to be someone who has to be accountable, right? If something
absolutely.
goes wrong, right?
Absolutely, 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 absolutely. So it will still need human validation. And how will AI augment engineers? So a lot of repetitive tasks that people are doing, that AI will definitely handle. Writing boilerplate code, some small little bug fixes, it will help them do faster. Optimizations
Sure.
will help. It will enable a lot of low code or no code development. So many people who are not skilled software developers, they'll be able to do some level of no code development. Business users can create applications or prototypes, without deep programming
Correct.
language, without deep programming knowledge. A lot of these things will happen. Debugging and testing will be enhanced. It will be faster. I think all in all, AI will empower engineers, making them more productive, more strategic, but human oversight will remain very, very critical. What will happen is that if a company has 100 software engineers, they used to develop in an year, probably now they will do it in 6 months. So speed will increase, which means the same company will be able to produce more.
Delivery will be higher.
Yeah, remember, see, do you remember this famous meme or quote? I don't know if it's true or not, but like it says that once upon a time, like in 90s, some or maybe in 80s, Bill Gates said that 640 KB ought to be enough for anybody.
Correct.
Right? I think he was talking in terms of computer memory, and he said that 600 so at that stage, so people were not able to think the use cases of future. So based on their current capacity, they thought that 640 KB is good enough. If a computer has 640 KB of memory, it's good enough. But we know now over next few decades, new use
Things have
cases have
completely
come.
changed.
And today,
Right.
nobody even uses the word the
KB.
KB anymore.
Right.
Right? When you talk of
Correct.
so
Absolutely.
new use cases will
Things
come.
have completely changed.
Things have completely changed. It will keep changing at a faster and faster pace.
Mohit, I mean, considering all the advancements of AI, how can, engineering teams practically integrate AI into their, workflow so that they achieve higher efficiency and more innovation?
It's becoming straightforward. Actually, most of the tools that people are already using, they have to enable the AI-driven extensions of tools. Like, for example, code assistance. A lot of people are already using GitHub Copilot, Tabnine kind of tools, and then automated testing and CI/CD. They have to implement AI-driven test case generation. I was telling you, right, that Confluence is able to
Right.
write test cases for me now. When I say write test cases, I have not tried with automated test cases, but I've tried with manual test cases. It writes beautifully. In
Okay.
debugging and monitoring, a lot of tools like Datadog and Dynatrace, etc. They can predict failures before even they occur based on the trends, etc. For customer insights, analyze user behaviors to prioritize high impact features. Documentation, already I gave you examples of how AI is big time helping in documentation. And what we have to understand, Pradeep, is when I say it is helping in documentation, actually, maybe that's a little bit of misleading statement. Documentation is always a output of certain activity. For example, if somebody is writing software requirement specifications,
Mm-hmm.
the documentation is output. What he is doing is he's defining the product, right? Or if somebody is writing an architectural document. So what he is doing is actually thinking and deciding the architecture. So when we say that AI is helping in documentation, actually what it is helping is in defining product. It is helping in defining architecture. Maybe that's a
Right.
better way to put it. Teams should focus on AI assisted development, intelligent automation, and AI driven insights to accelerate innovation. And I think in few coming years, and as we move forward, earlier society was split into haves and have nots, right? Now it will be AI haves and AI have nots. Right? Those who use AI, the developer community will be of the successful developers will be who use AI at every step, and others will be the non-AI users.
So, Mohit, what are some of the biggest today? What are biggest misconceptions about AI? In engineering leadership, which you can see.
So let me think. Many.
Okay.
So, yeah, I think many people are still, they have a superficial understanding. So, they have developed certain misconceptions. Like, for example, one of the common misconceptions I keep hearing again and again and again is that AI will fully automate software engineering. And we just now discussed just a few minutes back. AI can assist. It will not replace. It will assist.
Mm.
It will
Right.
make it will make that current developers like super developers, but it won't replace because someone has to still do it. So decision making will a lot of decision making in terms of engineering will still remain human driven. Then people think that AI always provide accurate results. That's not true. AI hallucinates. All AI hallucinates. AI models need fine tuning, and there are biases in AI models, right? They give
I
wrong
would
information.
mention something. I had asked some kind of mathematical question on account of my daughter to this llama, okay, the one released by Facebook.
Uh-huh.
And to my surprise, it gave me a wrong answer.
Yeah, yeah,
So I think it is still evolving a lot. I mean, there is still,
yes.
it's not completely reliable in a lot of
It's
ways.
not. It's not. And I am pretty sure the question you would have asked must have been a simpler one, relatively, right?
Very simple question, actually. I don't even want to put it here.
Even in simple questions, it hallucinates. I think maybe in next year or two, as it advances, those simple questions it won't hallucinate. But there are bigger questions where it will hallucinate, right?
Correct.
So it will never be. I don't see at least in next 5-10 years it being so perfect that it is always accurate. Which actually is a also it creates a little bit of problem because which
Right.
means it is not, you can't just take any answer from AI and mindlessly use it. So
Mm.
you still need extremely intelligent people to challenge the answers and improve it, correct it, and then use it.
So basically, they will need to imbibe all that mistakes and kind of better tune their models so that going
Correct,
forward it is more sharper, more accurate.
correct. Like for example, anything. If you ask a question about database design, let's say you are designing your database architecture, and it gives you an answer. Or let's say you are designing your microservices architecture, it gives you an answer.
Mm.
That answer has to be validated by someone,
Correct.
and
You
that
cannot
someone
trust
has
AI
to be
blindly.
expert in that, right?
Right.
It's not that someone who doesn't know what microservices is cannot validate it, right?
Mm.
If you ask AI a legal question, like AI is very good in writing, right, generating text,
Mm.
so it can generate,
Correct.
for example, legal petitions, etc. for you. It generates, but someone who really truly understands law has to then
Validated.
validate it. And AI can hallucinate. It may refer to a court case which never ever occurred, and it will do.
Cannot differentiate between imaginary and
Yeah.
factual data sometimes, right?
And the funniest thing is that it will do it so confidently that you will think it must be true. Yeah, because the answer will come in a very, very confident language. The
Correct.
phrasing of the paragraph will be so confident. It will never say that, oh, maybe I think there was a case, such and
Right.
such case in such and such court jurisdiction. It will say
Yeah.
such case happened in such and you will just feel that as if it's true. So I think
That's slightly scary also.
it is not always providing accurate results, and which means that a lot of expertise is needed to
Right.
use AI tools properly. Then there are many other, like for example, people say that it will reduce a need for skilled engineers. I don't think so.
Hmm.
Then
Okay.
many people think that AI is only for very big tech companies. That's not true.
Hmm.
A lot of tools are now accessible to everybody, as startups, small business, even to individuals. A lot
Mm-hmm.
of tools are accessible. Many of them, the better models are on subscription, but these subscriptions are not very costly.
Correct.
Sometimes, $15-20 a month is what, like ChatGPT is charging what, $20 a month, something like that, right?
Correct.
So $20 a month is quite affordable for having an assistant who's always available to help you with every matter.
Right.
So
See,
people need
Mohit,
to align their expectations with the reality when it comes to AI. But for that, they have to understand the reality.
you have to understand actually how AI works and probably get used to it before
Yes,
making any bigger decisions using AI.
yes, yes, absolutely, absolutely.
Also, nowadays AI is also used in hiring quite a lot. How do you prevent AI from becoming a bad hiring manager?
AI hiring, yes, it is increasing, and I think it will increase even more. I think behind the curtains, LinkedIn was anyways using AI. One of the problems, I have not used LinkedIn from many years now for the point of view of a job search. But I've heard from people that these days, last couple of years, people are saying that it is becoming more and more difficult to find jobs via LinkedIn.
It is becoming spammy. I also
It
feel a
is
lot of
becoming
spam is
spam.
there, and yeah,
Because it is just overwhelming, it people are telling me that it is showing you so many options, and and maybe for an HR also, it will just show you, give them so many
I
CVs.
also feel sometimes it has become a tool for people to capture data, gather a lot of data. They will just post a fake job, and a lot of people will apply through it. So they will just gather the resumes and all that data and probably use it somewhere. Correct.
And then is data driven, right? Models
Right.
behave the way data is. So if your training data is biased, which normally will be because it's a real life data, so those biases will come in hiring as well. Like for example, if your past data suggests that you have more employees from a certain race, for example, or let's say for a particular role, all your past data is suggesting that more and more people or maximum number of people are from one specific gender. AI will think that maybe gender for AI is just a parameter. So it will think that, yeah, maybe race and gender are important filtering criteria. So that brings biases, right? Human judgment is missing. So very unconventional candidates will get filtered out. Like sometimes when you are interviewing, it doesn't happen very often, but sometimes, you get across an unconventional candidate who may have done not exactly, who may not have exactly the same skill that you are looking for, but maybe you decide as a human being that, as a human interviewer, that, oh, this guy is highly trainable and he's a super genius.
Capable. Capable.
He's highly capable, highly trainable, super genius. Maybe he doesn't have that skills of two or three tools that I'm using. And then you are able to take that judgment call that fine, those tools he will learn in next 2 months, right? AI will filter out such candidates. So those kind of
Yeah,
videos,
because AI will only go through the resume. It's not actually interviewing the candidates, right? So
yeah.
you're right.
So pattern, because AI will at a very abstract level, it is matching patterns, right? So
Correct.
somebody who's not fitting a pattern will
Mm-hmm.
get uh,
That out.
filtered out, and it's a problem. So
Hmm.
there are ways to prevent AI from making bad hiring decisions. One is that humans should be always in the loop. Use AI for screening, but final decisions should involve human recruiters. Again, use it as an assistance. Don't rely too much on it. Use very diverse training data. Now, one of the challenges that training data, many companies who would use the AI driven HR tools, will not be training it themselves. So it is beyond their
Correct.
control. But for example, people will use LinkedIn. But if LinkedIn is using not a diverse training data, then that will create problems, right? So train the AI on very inclusive, unbiased data sets to avoid this kind of gender bias, race bias, or any other kind of bias. Explainable AI has to be used. Like use AI models that provide transparent reasoning behind the candidate selection. If you would have seen this new, I think, what is it called? GPT 4.0. No, not 4.0. What is the new model that they have released? O1, I think. So O1 gives reason.
I think 1, 2, 3, 4 then became O1, I think.
So
Something like
O1
that. Yeah.
gives reasoning. Like 4.0 was the earlier one. Now O1, the new one that is released, this gives the reasoning.
I think even DeepSeek also gives its own whole chain
DeepSeek
of
also
thoughts
gives
that it is
reasoning.
going
Yes,
through.
yes. So you have to use those kind of models which are transparently telling you how they arrive at the decision. That those kind of AIs should be preferred. And periodically, people have to keep auditing the AI decisions, review the AI decisions, see what kind of mistakes it is making. So key thing is use it as an assistant. If we think that okay, by you doing this, I'm going to replace the human decision makers, that's where the fault is. It's an
So,
assistant.
understood. What role will AI-powered no-code and low-code tools play in future of engineering?
A lot, a lot. It's
Okay.
already happening,
Okay.
right?
Okay.
A lot of low code or no code is already happening with AI. AI powered drag and drop platforms like Bubble, Out Systems. They are
Remote apps.
enabling non-developers to build applications. There are many others. I may not know names of.
We had worked on one called Microsoft Power Apps. That was pretty good. But yeah, there are many, I think. Yeah, you're right.
There are many and more will come. I have not used it, but there are lots of them
In
there.
fact, I have heard about those no-code apps directly creating I mean, the mobile apps also.
Yeah. Yes, absolutely. Then AI tools can generate code from natural instructions, right? Copilot is already
Right.
doing it to some extent. So it's doing it. In fact, on GPT, let's say if you ask it to create a map on, let's say you want a world map where you want to show the most populous 10 cities or something like that, just give that
Mhm.
instruction, it will generate the entire code. You put that code in any runtime environment and it's just there, and it's
I,
pretty error free.
okay.
So already that's happening. Like people are using it. A lot of people are using it. Faster prototyping it will help in. People can make
Okay.
MVPs and prototypes very fast using AI assisted no code platform, right? Engineers will focus. I think one of the shifts that everyone has to understand is engineers need to focus more on conceptual things like architecture, optimizing of systems, scalability. That is what engineers have to think. The engineers which are just coders, they have a competition now. But does it means people don't have to learn code? I think they'll have to still learn because unless you code, it is difficult to even imagine a great architecture, right?
Just true.
I have never seen good architects who were never a great
Orders.
so I think that's the learning path.
Hands-on thing should always be there.
Yeah, and I'm not able to imagine can this that will that change, at least not in near future. In fact, in many cases, at least in software industry, I have not seen good product managers. Like the good product managers that I have seen were always at some point in time software engineers themselves. That's my experience. Maybe I have a small data set. So
Even I have seen actually many product leaders
yeah.
who are actually engineers, and that has helped them because they were also used to do a lot of big POCs, a lot of they can kind of generate data and then apply that into products. So the
Hmm.
dependency sometimes reduces a bit on engineering and kind of yeah
Absolutely.
that helps.
Yeah, so no code tools will not replace skilled engineers. They'll handle complex system design, assist, performance tuning may they'll help, integrations they'll help. It won't replace, in my opinion. It won't, I'm not afraid that it will eliminate the deeper expertise, people with deeper expertise. So AI is not just changing software development. It is not changing. More than that, what I'll say is redefining it. As an engineering leader, I see AI augmenting engineers rather than replacing them. And companies that effectively blend AI with human expertise will have a competitive advantage. And while implementing many of the earlier known use cases will become easier with and faster with AI, many new use cases will come up. Like how I was giving this example, right? That with the advent of internet, newer use
Mm,
cases came up, which were
right.
unthinkable in 80s and 90s. So same thing will happen. We'll see new use cases that didn't exist so far.
Sure. So Mohit, according to you, since you've worked with so many startups and in large companies, what do you think differentiates a great engineering leader from a good one?
Good engineering leaders versus great engineering leaders.
Yeah.
So good engineering leaders focus on things like, that they ensure that projects are delivered on time. They have a lot of focus on time and task execution. They are taskmasters. So, and I've seen very good leaders who are very good in terms of making sure that things move, things keep moving, projects are delivered on time, teams are efficiently managed, system keeps running. They focus more on technical execution. They are taskmasters.
Focus on the how of the question, how to do things faster and
More
better.
than how their focus is on time, which is a good thing, especially in a fast-paced environment is very good thing. But they also see engineering as some sort of a rat race, right? Who is faster than, whether A is faster than B or not. Now, I think the great engineering leaders, they have different traits. First of all, they inspire and elevate teams beyond the day-to-day technical execution. They provide a balance of vision, strategy, and execution. I've seen some very good taskmasters who are not able to talk in terms of vision and strategy, but they are very good taskmasters. They are very, very good in reminding
Execution.
people that today this has to be done, this week this has to be done, this is the timeline coming, and if the work is, let's say, lagging a bit, they're very good in speeding it up by sometimes nudging people properly. But when I don't see a vision statement coming or a strategy ideas coming, then I think they are not, I would put them in good rather than great. A great leader, he will empower engineers to think innovatively rather than just following orders. A great leader will make bold but calculated decisions that drive innovation. So a lot of it can be judged whether the innovation is happening in a team or not. If the team is innovating, the leadership is great. If the team is delivering, then that leadership is good.
That's interesting. Okay.
If no innovation is coming, then it
Mm,
can be very good. But a
okay.
great leader will bring up innovation. And innovation is never one brain's output. Real innovation comes. There's a very interesting phrase. They say wisdom of anthill, which means that what's an anthill? This colony where ants live,
And live correct.
right? So while an individual ant has a very tiny brain, I don't know what kind of brain it has, but imagine a small little ant, it will have a very tiny brain and it cannot do too much of, it can do only specified things. But a full-fledged ant colony, it is actually able to build a whole very complex network of tiny tunnels, and their home is so amazing, right? So there is a wisdom in the group work. And great engineers are able to harvest the wisdom of a group thinking instead of completely relying on what they think. I think a very key ingredient is that a great leader always respects their engineering teams and they respect the expertise that each person is bringing on the table. They don't evoke fear in their teams. They operate with respect. I think that is a big difference between a good and great.
So how should the leaders, scale their engineering teams while maintaining agility also and innovation also?
Scaling, yeah, scaling. I've seen in some situations, I've been in situations where scaling becomes very difficult. And there is this book called What Brought You Here Won't Take You There. A very nice title. I've not read this book, but the title is so beautiful. What Brought You Here Won't Take You There. Many teams are able to reach to a certain level and then scaling becomes difficult. So there are many pitfalls, that they have to avoid while scaling. Some of the pitfalls they have to avoid is stop overloading teams with lots of tasks, all to be done in parallel. That slows innovation. I have seen, especially in India, I have seen this phrase used very commonly. You ask somebody what is the deadline for some work, they'll say it was yesterday, and then they will, with a smug smile, for all. Have you heard this? Yes,
I've heard
deadline
it,
was
I think.
yesterday,
Yeah. Yeah.
right? I think there is this tendency of thinking that if I use this kind of language, I am looking very smart, and it will put pressure on the team, and they will work day and night, and quickly do things. What people forget is when you want everything very, very quickly all the time. I mean, I understand if certain times, sometimes a project, sometimes people have to, buckle up and speed up. But if it is happening all the time, invariably it results in poor quality. Invariably,
The
right?
productivity will be affected eventually.
Productivity will be affected, people will start lying, and lots of things happen, but invariably the product quality deteriorates. I have seen teams which claim to work all the time very, very fast. Often their product is poor quality. And hiring too fast without maintaining strong engineering culture is another pitfall they have to start. Like you have to hire the right people. Cross team collaboration should never be ignored. It leads to silos. So some of these things I say that these are the pitfalls that have to be avoided. On the other hand, there are some best practices that can be used for scaling without losing agility. So few things that come to my mind is hire for adaptability, not just technical expertise. Look for engineers who thrive in ambiguity, love problem solving.
Right.
Hire people who are very adaptable. May not have the exact technical expertise that you need, but if they are smart, they'll pick up that technical expertise. Then promote a culture of ownership. Small autonomous teams innovate faster than heavily
Okay.
structured ones.
Sure.
Prioritize tech debt management. Scaling too fast without handling legacy issue, it has a snowballing effect on tech debt. And after few years, it becomes impossible to scale it up. And it becomes impossible to even replace a bad architecture. And I have seen it, I'm sure you have seen it. That's why maybe you are
Correct. Right.
we have seen the same thing. And maintain a startup mentality. Even in a large enterprise, startup mentality should be maintained.
Okay.
Experiment. What is startup mentality? Encourage experimentation. Let people experiment and have that fail fast approach. I think those are the things.
As a next startup founder, right? What engineering practices differ between startups and, let's say big enterprises?
A lot. I think a lot. There are a lot of differences. So look, to begin with, startups are fast paced, right? They are fast paced and agile, whereas large enterprises are structured and scalable. Right? I'm not saying which one is good, which one is bad. I'm simply saying this is a difference, right? So startups will always prioritize speed over perfection. So they focus on launching MVPs and then quickly just iterating, which is good.
Sure.
Whereas large and stable enterprises, because they have a larger skin in the game and they are often the leaders, like I'm talking of leaders of the world market, they always prioritize scalability and perfection over speed. And I think in long run that wins, right? And most of the effective startups are able to transition very nicely from the first phase where speed is more important to the second phase where perfection is more important. Successful startups are able to transition, and those which are not able to transition, then it becomes a little difficult for them. Small companies obviously don't have any bureaucracy,
Mm-hmm.
whereas there's a whole lot of bureaucracy, very structured process, SDLC, approvals, etc., in large companies, which
Correct. Sure.
has its benefits, but I think sometimes it kills the spirit also. And cross-functional work is done more in smaller setups. Like engineers always wear multiple hats. Some same person will be doing DevOps, backend, front end, etc. Whereas in large setups, it's more specialized. Every role is more specialized, which has both have their pluses and minuses. So we should not say which one is better, which one. Like cross-functional people who work cross-functionally, they are very powerful because by the virtue they are cross-functional.
Right.
On the other hand, in large setups, because people are not cross-functional, so over time they develop very deep expertise, and that sometimes I see missing in startups. Very few people have deeper expertise. Most of the people have shallow expertise, and tech debt is more tolerated in startups. We have spoken a lot about tech debt, which is not tolerated in large companies. Small ones are very quick to embrace new technologies. AI comes, small companies embrace it faster. Large companies, on one side they have so much of compliance and security concerns and whatnot, they have so much of regulations, policies, so they are not able to adopt the new technologies fast enough. Whereas in small setups it's very easy. If a couple of people in the senior leadership, if they decide, that's it, decision done, payments made, technology is in use very fast. Those are the things. Decision making, there's a lot of difference in the way Pradeep, decisions are made in small startups and large
Okay.
organizations. And I think this is a very important difference, which I learned very late in my career.
Okay.
So what happens is smaller organizations are very fast and they're founder driven, right?
Correct.
They can make very quick pivots based on market needs. And large organizations, the decision making is group driven. It is not one person who goes and decides something. Decisions often involve multiple stakeholders. Now,
Right.
that makes them slower, but it also makes those decisions very well vetted. So there are pros and cons. In a small organization, the good thing is because the decisions are mostly founder driven, founder says something, everybody follows.
Correct.
It is very fast and there is very less inertia. But the flip side of it, the cons of that is this situation can get very, very autocratic. If the founder takes a suboptimal decision, there is no one to check and debate. And maybe I have made these mistakes as well. If I am a
So the
founder,
checks and balances are missing basically.
it's just missing, right? If I am a founder, I have made these mistakes, and this is coming from my own experience. If I'm a founder, if I'm making a mistake, there is no check and balance. I'd say something, almost everybody would just follow, what they're saying. Even if one or two people will express their a different opinion, a founder becomes like an autocrat, right? This is a big problem which I see happening. And in large companies, more brains are involved in a decision because it's a group decision. So more brains are involved. Of course, I'm assuming that all those brains are also competent people. And they
Right.
are competent in, it's not that large companies don't have competent, very competent people, right?
Correct.
More brains are involved for same decision, more thought is involved by multiple experts. So often the quality of decision is good as well as it is more long lasting. That I think is a very big difference. Risk tolerance is, of course, high in small organizations. A lot of other things, security and compliance is much more in large organizations, lesser in small organizations. Tools, etc., are different. Product evolution is also constant iteration can happen in a small company, which is very powerful. Whereas large organizations, they have very structured product roadmaps, long-term planning. Things don't change very fast. So those are the
So
difference.
let's say if you have to build your tech startup today, okay, from the scratch. So
Mhm.
how would you approach engineering today differently than what, let's say, you would have approached in 2015
How will I approach it differently?
if you have to build your own tech startup, let's say, from the scratch today?
So few things. Let's say I start with what would I do differently on the non-engineering side. So I think in my previous startup, I was too focused on product engineering right from the beginning. If I have to do it again, then I would focus more on building the market first instead of building the product. Even the product has to be conceived in the form of a marketing funnel. What does it mean? When you build a product, often you are thinking of what this product will do.
Correct.
Whereas a marketing funnel is a very different approach. It thinks about how somebody who doesn't know anything about your product will first start to know your name, then start to know what your product does, then do a trial of it, then do move to a more paid version and more enterprise level paid version. So it's a funnel, right? So I think the ideas of marketing funnel have to be embedded into the design of your company and of your product. This I would do differently compared to what I did last time. What happens is, see, I'm from an engineering background, right?
Mm,
There are two types of entrepreneurs. Those who come from engineering background, you and me, and
correct.
then those who come from non-engineering, let's say sales or marketing background, right? What I suggest is founders who are from engineering background in their early phases, they should focus completely on sales and marketing. And founders who are from sales and marketing background, they should completely focus on engineering. So basically, they should focus on what they are weak at.
The missing parts.
Are missing parts. Often, what happens is founders end up doing just the opposite. They start with what they're strong at, and then they are so engrossed in it that the other part they think that I will hire somebody who will do it for me, or I'll get a co founder who will do it for me. If some people might be 1% founders might be very, very lucky to find that complementary co founder, most are not. right? So then that part gets left out. So I think that is one of the lessons.
Mm-hmm.
I initially, when my last startup was there, there was hardly any AI buzz in the market, right? It was very experimental, and NLP was in infancy. Very less people even knew 10 years, 15 years back. Whereas now, if somebody has to start, if I have to start again, then AI is mandatory right from the beginning. AI powered development tools, chatbot, automation, etc. From day one, this has to be used. From day
Mm-hmm.
one, it cannot be an afterthought. Teams will be different. Like previously, instead of hiring full stack engineers and mostly freshers or very junior folks with 2, 3 years of experience, I think smaller teams should be, instead of hiring many engineers with lesser experience, what works better is to hire less number of engineers but with much more experience. Okay, because that brings the maturity right from the beginning. Because if we start building a product with less experienced engineers, right from the beginning, many wrong decisions get taken at every level. And
Mm-hmm.
over few years, it becomes a big ball
Problem.
of problems, right? So hiring mature engineers at the beginning is very important. I think
Okay.
less experienced engineers can be or should be hired only at a later stage when the company is already very stabilized, as well as these more experienced folks then can train the lesser ones. Otherwise, you hire freshers and there's nobody to train them. And build an MVP first, iterate later. That was
Okay.
the original
Idea. Okay.
older idea. I think now it is better to use no code or low code tools to launch very faster and then do AI
Mm-hmm.
assisted engineering. So key takeaway is that in 2024, approach leverages the AI cloud automation no code tools. Build fast, smart, and scalable startups. Things are very different in 10 years.
So, what kind of advices would you give to some engineers who are in their early careers, right? If they want to stay relevant, in this rapidly evolving tech landscape, what advices can we give them?
Be completely aware of new technologies, extremely be aware of learn fast, learn it very very fast, learn AI very fast, learn automation very fast. AI won't replace engineers as we discussed earlier, but engineers
Mm-hmm.
who use AI will replace those engineers who don't use AI. So that should be like the number one topic on everybody's list. Master cloud and DevOps. Companies are moving towards cloud native architecture. All engineers have to early stage, they have to understand serverless, Kubernetes, CI/CD, all these things, early on. Develop business awareness. Often engineers, especially in India, they don't have a business awareness and they don't even try that, which I think becomes an impediment in their growth later. And with the way things are changing, it is those who are able to blend the business awareness with technology, they will be the winners. Only technology, only coding, you can't win with that. Things are changing fast, and I think next 25 years things will change faster than ever before. So be very, very adaptable. Best skill isn't a specific language. It is the ability to learn a new language quickly. Which language you know today, maybe in a year it may get obsolete. Who knows? There are some
Of
newer
course.
languages will come. So what is more important is how fast you can learn a new technology. Make your own personal brand. Share your knowledge on GitHub, LinkedIn, blogs. Do network. Open doors with networking and
Okay.
make a personal brand. I think all engineers have to think about making their personal brands. Use social
Be
media.
relevant on the internet and kind of by participating in some open source projects and all those
Right,
things.
right, right. Social
Okay.
media and internet is so powerful. It is like a university, right? But unfortunately, we all are seeing that lot of people, both in younger generation as well as in our generation, lot of people use social media predominantly for entertainment,
Oh,
right?
right.
Like for example, they would be browsing through Twitter. Even I do it. It's not that I don't do it. Browsing through Twitter or Instagram, YouTube videos,
Reels and all.
reels and all, right? Lot of it is entertainment driven rather than knowledge driven. Whereas social media and internet is a vast pool of knowledge, and people need to they need to
Utilize that.
yeah. There are tools. People try to think in terms of screen time. I have to reduce my screen time. Maybe what they have to think is you don't have to reduce your total screen time. You have to reduce your screen time for entertainment. And you have to increase your screen time for high quality content, right?
Basically, you have to channelize your energy where you are kind of spending your time and getting something out of it, right?
Exactly, exactly, exactly. Instead of wasting time on some reels or, I mean, I don't
Mm.
want to take any names, but these days so much of low quality content is floating all around, right? And it low quality content becomes viral fast. So be
It
careful.
catch the attention of people, and I think their attention span is also decreasing because of all these things.
Yes, and see, if something is really viral, high chances are it is low cost. Why? Because viral by definition means that millions and millions of people are watching it. If millions and millions of people are watching it, it cannot be very intellectual, right? Because your intellectual population percentage is small. So
Right.
so be very careful. Be a little wary of such kind of things.
Content. Okay.
Right. And another advice I would give is become T-shaped. T-shaped means have deep expertise in one area, but working knowledge
Okay.
in multiple technologies, right?
Okay.
So
That's a
have
very good advice. Yep.
deep knowledge, yeah. I think those are the things people, young engineers should focus upon.
And so, how should engineering leaders, balance between technical expertise and, let's say, business, the business deliveries? Because both sometimes kind of take a lot of your time and energy, right? And you can focus on one most of the time. So, how should engineering leaders, balance between technical expertise and also kind of their business deliveries and business goals?
I think first of all, I think that some of the things that I said earlier, like
Mm.
have very often, especially in smaller startups and setups, leaders tend to hire more and more people who are at a very, very entry level. And they don't balance their team with the with more matured stuff. So if you have a team which is more balanced, more people will be thinking on these needs, not just the founder. So uh, so the right balance have to be found, like for example, we spoke about balancing between tech debt and speed.
Correct.
So don't ignore tech debt. Allocate 20 to 30% capacity for in every sprint for your tech debt reduction. If your tech debt is already very high, maybe higher capacity. Get your capacity allocated to tech debt reduction. Then saying yes to every deadline, right? Remember, I was talking about learn to say no. Saying yes to every deadline leads to burnout, and burnout leads to poor quality.
Mm.
All
True.
this discussion of people working 70 hours, 90 hours, 7 days a week, no, it will result in burnout. Burnout means your own product quality will be poor, right? So saying yes to every deadline leads to that. And instead of that, leaders should push for sustainable velocity instead of short-term speed. Adding unnecessary features to look busy, like this feature, that feature. No, have less number of features. Focus on impact-driven development. What truly moves the business forward. Build that. Don't build everything. Don't try to build everything. Don't try to build every
Okay.
idea that comes to your head, right? Over engineering instead of shipping fast. Avoid that. Aim for scalable and maintainable code. Prioritize business outcomes. So great engineering is not just about code. It is about solving real world business problems efficiently and in a way that your solution keeps working without assistance. Like if you have sold your product to when your customers or when your users are using your product, they should never need an assistance, right?
True.
That is
Okay.
what is the goal.
So, if you had to rewrite this whole software engineering rule book for, let's say, 2030, what are some of the key software principles that you will include?
Key principles will be same, AI
Okay.
first development,
Okay.
human AI collaboration. Engineers have to orchestrate with AI, not just write code. Code native, cloud native by default. On-prem infrastructure it's already reducing. But on the other hand, what is also going to happen is that more devices which are of the nature of IoT and edge compute will
Mm.
increase. So for
Okay.
many, so there will be two types of applications. Certain type of applications, more and more will be on the cloud, which is already happening from
Okay.
last 10 years.
Okay. Okay.
But newer use cases are going to emerge where it will be where it will be more focused on edge compute. Edge compute means you are able to run more complex and heavy algorithms on the device rather than on the
Correct.
cloud because you don't want to
Right.
keep moving data all around the cloud.
It will also decrease the amount of compute that you need to do on the one server, right? So it will get spread. You are utilizing the capacity available with all the devices.
No, no, no. I'm saying, no, no, no. I'm saying that capacity of devices will increase big, big time.
Correct.
right? Like the
Mm,
processing power, the memory the people are moving more and more towards GPUs, for example, more and more
mm,
powers of GPUs. So processing power on devices is going to be increased manifold, which means there is a opposite shift. Any of in last 10 years, almost everybody was moving towards that everything will be done in cloud. Now, I'm not
mm,
saying things won't happen in cloud in future. A lot of things will still happen in cloud.
mm,
But many new use cases will be where your large models are actually run on your computers, on your
mm.
devices, on your phones. Like I was reading somewhere that I think the newer models of iPhone are going to have a LLM on the phone.
That's what I meant when I said that all those computation, instead of happening in one single place, will happen in multiple
Will happen in
devices.
all devices. Yes, yes, yes. It will happen locally. So
Correct.
those, right, yeah. Then security first mindset has to be there. Engineers has to think like ethical hackers. Security is going to become a challenge with more use of AI. Data security is because it's hard to keep a control on where my data is moving.
Correct.
Companies should stop being feature factories. Like just it
Okay.
is not important that you keep making feature after feature after feature.
Mhm.
Make those features that are having more user impact or business impact, and whatever features are released have to be of impeccable quality, and there is a lifelong learning culture. Everyone must constantly evolve. Now this is good and bad, but this is how the world is going to be. Everyone has to learn. It gone are the days when you would pass out of your college and university and your learning gets over. No,
You
keep
have to
learning.
learn continuously.
Yes, one
Okay.
has to keep learning continuously because things will change. What you have learned last 10 years will be irrelevant next 10 years.
So thank you, Mohit, for the detailed answers. So Mohit, where can all the people who are listening to you today, they can follow you or connect with you?
People can follow me on LinkedIn. People can follow me on Twitter. People can follow me on Instagram. I mean, you search me by name and you will get it.
Okay. And so also, Mohit, I would like to come back to you and discuss again about your book, The Textbook to Happiness.
Oh, I'll be glad to talk about it. Yeah.
Sure.
It's right
Okay.
now it is one of the projects which I am quite I'm spending a lot of time and thinking cycle towards it.
I think once it is in some shape, and then we should reconnect and kind of discuss it.
Yeah, why not?
Any upcoming projects or talks that you want to share with us that you're going to give?
The book that I'm writing, that is the main thing.
Mohit, thanks a lot for your time. It was great talking to you. I think we have discussed a lot of things today, whether it be about engineering in general, AI, leadership, engineering leadership, and business outcomes, how to drive business outcomes better, and be innovative. And I'm sure people who are listening to this podcast would be delighted to connect with you. Any closing words, Mohit, and then I think we can wrap this up.
Well, I see that I'm glad that you are running this YouTube channel. My closing words are, all the best wishes that your channel becomes superbly successful.
Thank you, Mohit.
Whatever, in whichever way I can contribute, I would like to keep contributing to your channel.
Thanks a lot, Mohit. Glad to have this discussion with you. We will reconnect again whenever we get time and whenever the book is launched. Okay.
Okay, all right.
Thank you, Mohit. Thanks a lot.
Thanks, Pradeep.